if one person places one hand this way, another person places his hand. Will you be able to compare them? Tell if one of them is bigger than the other, perhaps? Well, no, right, because they are not aligned together, right? This alignment is also very critical for digital twins. If we have sequential data from a point cloud, we want to have it aligned together with a BIM model so we can analyze and compare automatically. So my name is Miguel Vega, and today I want to present you a method that contributes to achieve this alignment automatically. So, but why is this important? In the project I'm working on, we try to support first responders to have an aligned map with BIM model so that they can increase institutional awareness, know the magnitude of the disaster, and they can also take better decisions how to rescue victims effectively. And but not only for first responders to learn this skill, but for the manager, so that they can do a BIM-SLAM operation. However, this this is for real and they have no problems. For example, the sensor process I decided to be able to apply the sensor and the map of the environment. The map accuracy is limited also to the real-time performance of the algorithm. And if we don't have a reference BIM model, we will not be able to create a map. Because if we don't have correspondence between what the sensor measures and reference map, we will not be able to calculate events. Yeah. Well, so now it's better. Yeah, so in order to find a solution, we have tried several approaches to handle these robots. And the solution we found is inspired by multi-session SLAM. Here you see, for example, a visual SLAM and LiDAR-based SLAM. So you see different trajectories of the same map, and they can be then aligned together into a single reference. However, these methods try to align a sequence with each other and break them all together. What we want to have is a method that uses the reference map and aligns on the map. So our contribution is divided in 3 main steps. First, the creation of session data from the BIM model. Second, the ground truth multi-session and coherent, where actually the alignment happens. And third, the change detection and map update, where basically we try to analyze the aligned data. So to create session data from the BIM model, we use part of a previously developed pipeline enhanced with Gazebo to simulate 3D LiDAR sensor. And with that, we can come from a BIM model into a trajectory that scans the whole rooms of the environment. And this has nodes on edge. And for each node, we have then a point cloud. Each point cloud, we have descriptors. So basically, what we are doing is coding the geometry of the BIM model into point cloud descriptors. So in the second step, we want to acquire real session data. And for that, we develop a snapping system that is very cheap and can be used over any robot without ground surface, or also as a control system. And here you see it over the Google robot. So after that, we acquire sequential data with the robot, LiDAR data, we can input this into a scan context LiDAR SLAM, which basically takes as input the output of almost any SLAM system like LO, CO, LeoSLAM, and give us as an output scans, descriptors, and postgraph. So now that we have the ground truth session from the BIM model and the query session from the real data, we can then compare descriptors between each other and find correspondences. Once we have found certain correspondences, we can calculate the best alignment of these two sessions, adding what is called the anchor node factor into the bottom optimization problem. So this anchor node is proportional to this expression, which we want to minimize iteratively. And after optimization, we will find that the anchor node of the query session, depicted here with delta Q, will give us transformation of the query session, or the possible of the query session that best align these scans with the ground session. So basically, coming back again to the analogy, we can say that this is the reference map or BIM model, and we can have a drifted map with SLAM. So with the possible optimization process, we bring them together and reduce the drift of the SLAM map. So here is how it looks with the real scans. See, you have a drifted map, and you correct it, align with the BIM model. This is done in GTSAM and use incremental response. So finally, to analyze the data already aligned with the BIM model, we try to detect positive differences in the environment. Doing a point cloud to distance, mesh point cloud distance computation, DB scan clustering, and voxelization. After that, we have new elements with different colors in the environment for better visualization. So regarding the quantitative results, we compare our method with a context alone. So after alignment, manual alignment of the trajectory of this SLAM algorithm with the ground truth, we see that they are actually quite close to each other. But if we have a closer look, we see that BIM-SLAM actually has a lower absolute post error during the trajectory, and lower values of the absolute post error. In fact, the root mean square error is 2 centimeters lower than this SLAM algorithm. So what can we conclude? We have a method that achieves the alignment and correction of sequential LiDAR data model. However, it's not offline. We can create real maps even if we don't have a reference map of environment. And we allow also map extension. So if we can even scan only a partial section of the reference map, we can then achieve the alignment with partial overlap and extend the map. We can also detect positive differences and segment it for better visualization together with the model. In the future, we would like to be closer to the ground truth process reducing our root mean square error, and to be able to detect negative differences, basically elements that were present in the BIM model but are not present anymore in the reality, and also to be able to handle large scale BIM models. For that, we have been working with the newly released BIM-SLAM dataset. See here BIM and the map created with SLAM, and with BIM-SLAM we can then align and correct it. So references and retention and to answer any questions.